awesome to have all of you here with us again on this Thursday afternoon. This is our third lesson, if I'm not mistaken, fourth lesson on inverse functions. And as we were discussing last time, I just want to do a brief recap of the exponential function, because it's only when you understand the exponential function that you can understand the logarithmic function. And in my opinion, if they do ask you for inverse functions, it's probably going to be either a question on the inverse of the quadratic function, which you have to restrict the domain for it to be a function, or it would be a logarithmic function. More than likely. So yeah, understanding the exponential function really is super important. Okay, so when we first do the exponential function in grade 10, all right, we learn that exponential growth looks something like that. Okay, and if this is our x-axis and that is our y-axis. And what this sort of growth represents is things that start off growing quite slowly, and then there's a sort of a really rapid increase. So like a few examples of this in real life would be things like the way fire spreads, and human population has also grown exponentially, and the use of smartphones is also can be considered exponential. There's lots of, it's pandemics, so like COVID and that kind of thing generally grow like this. Any kind of culture in a laboratory, so if they're trying to grow bacteria or something like that, it'll also grow exponentially. So these things have got a lot of applications in the real world. That aside, even though that's the most interesting thing for us to talk about, if this graph is the typical graph y equals 2 to the x, this means y equals base 2 to the x plus 0. So in other words, the value of q, the horizontal asymptote, is equal to 0 in this regard. Okay, so again, q can change its value depending on what we do to the graph. So if q is positive, then we've shifted the graph up. If q is negative, then we have shifted the graph down. Okay, what's super important for us to realize here is that in this form, the x-axis is an asymptote, the one and only horizontal asymptote that these functions have. But I want to ask you why. Why is it not possible for this graph to touch the x-axis? Does anybody know why? X keeps getting smaller and smaller off to the left-hand side, but it'll never, ever reach 0. Why? Why does that happen? What's the reason for that? The reason is because it does not matter what you make your exponent. You could make your exponent the smallest number you could imagine, the most negative number you could think of, right? Those zeros could go on forever and ever and ever, and we would still get a positive answer. So our answer would be 1 over 2 to the power of whatever it was. It would be the most minute, tiniest little fraction in the world. But there's nothing that we can raise to 2 in order to get 0 or a negative out. Okay, so that's the reason why the x-axis is an asymptote and the graph will never ever touch it. Okay, in this form, we need to know that what this really means is y equals 1 times 2 to the power of x. This 1 over here, that can also change in value as it becomes bigger and bigger. The graph becomes steeper. But you don't need to worry about this too much with inverse functions. That value won't change. But what is important to notice is one that I have drawn in pink. When it is positive, the graph is sketched above its asymptote. So often in this form, we could write this as the graph of y equals a to the x, or we could write it as y equals b to the x. It really doesn't matter. So the coefficient of this, which we could give another letter to, as long as that value is always positive, the graph is going to be sketched above its asymptote. Okay, so graph sketched above asymptote. And then, of course, the other thing that's important for us to take cognizance of here is our domain and range. Okay, so as far as our domain is concerned, x is an element of the real numbers, okay, because the graph keeps going in both directions. And then as far as y is concerned, we would say that y is greater than 0. That would be our range. When this graph is reflected over the y-axis, okay, now I hope you're listening carefully to me when I say this, reflected over the y-axis, that is not an inverse function. It's just a normal reflection over an axis, right? It looks like this. Also go through there and it would continue to get smaller and smaller. Okay, so it's supposed to be a mirror image of the blue line. You'll just have to pardon my drawing. It's not very easy to draw these functions on this pad. And this particular graph, because it has been reflected over the y-axis, what changes sign? X changes sign when we reflect over the y-axis. So this becomes 2 to the minus x. But of course, we don't write it with a negative exponent, and that's where we get 1 over 2 to the x from. Okay, so we write it as the reciprocal and we give it a positive exponent. That's using our negative exponent definition. All right. Again, the invisible 1 that's sitting over here, all right, the graph is sketched above its asymptote. Again, here we would say that x is an element of the real numbers, and again, we would say that y has to be greater than 0. So there's not too much of a change between the two compared with that. Right, so it is mainly these two functions that we study the inverses of. I've never seen them, whilst it still sort of lies within our syllabus, I've never actually seen them ask log functions of the other ones. But just so that you are aware, I mean, you will need to know this in any event. We can now take these lines, the purple one and the blue one, and we can reflect them over the x-axis. Oh, sorry, there was one more thing I wanted to say. The blue graph, okay, wherever I measure gradient on the blue graph, it's always going to be increasing. And similarly with the purple one, wherever I measure gradient, it's always going to be a decreasing function. So we would say that, you know, the purple one is decreasing for all values of x. Or for the blue graph, we would say that it's increasing for all values of x. Okay, so let's take the blue graph and let's reflect it over the x-axis. Now, again, this is not an inverse function. When we reflect over the axes, these are not inverses, right? So the blue graph is going to end up looking like that. Okay, so that's what the blue graph would look like if it was reflected over the x-axis. What happens when we reflect over the x-axis, grade 12s? Y changes sign. Okay, so this graph that was y equals 2 to the x, now y has changed sign. Now, you would be forgiven for thinking that that means that the base is negative. It's not. It's this value of a that I was talking about. That's what's changed sign. So this really, what this really, oh gosh, wrong one. What this really means is that you've now got the graph of y equals negative 1 times 2 to the x. Okay, so y changes sign when we reflect over the x-axis. Okay, and as such, because this is now negative 1, what happens here is the graph is sketched below its asymptote. Okay, what's our domain? Same story. X is an element of the real numbers. What is our range? Y is smaller than 0. Okay, does that make sense to everyone? Any questions? Are we all managing? Okay, well, you don't have, I know you'll stop me and ask if there are questions. Okay, so now we need to talk about, okay, all good, cool beans. Okay, so now we need to talk about what happens when we reflect the purple line, okay, or the sort of pink line over the axes. All right, and as you can already imagine, that graph is going to look like like that. Okay, right. Similarly, this graph over here, wherever you measure gradient, it's going to be decreasing. Here, wherever you measure gradient, it's going to be increasing. All right, so if this is the graph of y equals half to the x reflected over the x-axis, again, when we reflect over the x-axis, what changes sign? Y changes sign, and that's where we end up with minus 1/2 to the x. And again, it's not the half, it's not the base that's negative, it's the coefficient. Okay, the number that's in front of the half and the number that's in front of the base that has changed sign, again, because the graph is sketched below its asymptote. Okay, and similarly, x is an element of the real numbers, and again, y has to be smaller than 0. Okay, and I've mentioned there that it's an increasing function. Is everybody happy with that? Okay, so they often ask you about reflections over x and y axes. Okay, and it's important to note with the exponential function that a reflection over the x-axis or the y-axis is not an inverse. Okay, so where do log functions come from? Well, the ones that we study mainly, okay, is going to be the blue guy, this one, and the pink one. Of course, the log functions of the other two exist, but that's sort of, as I say, I've never seen it asked in a matric paper. If we've got time to look at those at some stage, then I will do that. But those are not the ones that I want us to concentrate on. But the inverses of the pink and the blue one, absolutely, definitely. All right, so how does an inverse function fit into all of this? All right, so let me move over to the side. Sorry, I had that prepared to go through next, but I just want to go through this again. All right, so just quickly here on the side. Okay, I've gone over to the left as much as I'm allowed to. Let's just sketch another set of axes. Oh, hang on, sorry, I didn't want to do that using this. Oh, come on, delete. There we go. Okay, so the line y equals, hang on a second, what is going on? Sorry, guys. Are we back?
You're back.
Is everything okay? Sorry, I don't know what happened there. The screen just literally disappeared and it told me that I wasn't sharing anymore. It's funny, I have a friend at work and she and I always say that a classroom full of boys cannot make us cry, but a computer can. So that is for sure. Okay, so this is the line y equals x. So now we take that blue function that we were speaking about earlier, all right, this blue one here. And we reflect it over the line y equals x, right? And what we end up with, right, this is what we were speaking about last time, is a reflection of the graph over the line y equals x, and it looks like this. Okay, so can you see that that is quite different to the reflection of the blue graph over the x-axis? Can you see that that's completely different? Okay, because remember the blue graph reflected over the x-axis was our orange one. So reflecting it over the x-axis, and of course the blue graph reflected over the y-axis is the pink one. Okay, and this green guy looks completely different. Okay, so that is a logarithmic function. And as I was saying to you the last time, this is the one that they were actually talking about during COVID. All right, so y equals 2 to the x. So for the green one, what we would do is we would switch x and y around. So we would write x equals 2 to the y. And of course now, because we want to make y the subject of the formula, we've got to use logs. So we would say y equals log base 2 to the x. All right, so can you see how it's completely different? And similarly, all right, if I sketch the graph of, let's just stay here on the right-hand side. If I sketch the pink one, there's a set of axes again, and let's draw that decreasing function. Okay, so that was the one that looked like this. Okay, if we now reflect that over the line y equals x. Oh, that's a terrible line, I beg your pardon. Trying to get. Oh, here we go. That's what I wanted. Okay. If this is the line y equals x, then if this graph is reflected over that line, it ends up looking like this. I'm going to draw this one in yellow for you. Okay, now this is a little bit difficult for me. Oh, Lord. Sorry, guys. That's horrible. You know, last time I was struggling to draw this as well. No, that's nasty. You know why it doesn't want to. Okay, it's not awesome. I mean, this is supposed to be a smooth curve. So my apologies that it looks as bad as it does, but that's about the best that I can do under these circumstances. I'm sorry. Okay, so if this is the graph y equals half to the x in pink, then when it has been reflected over the line y equals x, it now looks like this. I'll write this in orange. Again, we're going to switch x and y around, so we would have x equals half to the y. We want to make y the subject of the formula, so y equals log, our base is now 2 to the x. And again, if I just take you back to the diagram that I drew earlier, you can see that that yellow graph is vastly different from either the orange or the purple. Okay, so it's completely different. Also, the other thing to note here is that your blue graph is increasing, and your green graph, your log graph, is also an increasing function. And it would be the same story down here with this. Okay, the pink one is decreasing. And thus the yellow one, which I'll write in orange because yellow is hard to see, is also decreasing. Okay, so that's what you need to be on the lookout for. Now, everything that I've just told you now, you need to know. That's your theory. You need to know all of this information. You need to learn the domain and range. You need to learn whether it's increasing or decreasing. You need to learn what the formula for or the equation for the function would look like. All of that sort of stuff. Okay, and then you are sort of fully prepared in terms of the background information to be able to answer these questions. So if we now go back and have a look at the summary of the two types of log functions, those are the two that I've just drawn for you. Okay, so if you recall, hopefully this looks familiar. The yellow one, this one over here, was the one I was struggling to draw. Okay, so that was like the yellow one. And then on the side over here, we drew the other one in, that was the yellow guy. And then this one was, oh, green. Oh, there we go. Okay, so let's just make it green as well. And then everything is color coordinated. Okay, so this is the green one. Okay, so learn the shape, learn what it's supposed to look like, etc., etc. Okay. The other thing that's important as far as theory is concerned, okay, is that the expression log base ax is only defined if a is between 0 and 1, or if a is bigger than 1. Okay, so in other words, a cannot be negative, it cannot be 0, and it cannot be 1. But why? Why can it not be those things? Does anybody know? What does A represent, matrix? If we work back to the inverse of the log function, if we work backwards to our exponential function, what does A represent? A is our A is the base. Absolutely. A is the base. That's exactly it. Okay, so Kumo, A is the base. Okay, so in other words, if I write y equals a to the x, okay, A is the base, right? Now, A cannot be 0 for obvious reasons. It cannot be 1, because if it was 1, it would just be a straight line, okay, because it doesn't matter what you raise 1 to the power of, it's always just going to be 1. So it would just be a straight horizontal line, y equals 1. And it also cannot be negative. Why can it not be negative? Again, it goes back to this theory that we were talking about up here. It does not matter how small we make, where was it? It does not matter how small we make our exponent. The graph is never ever going to touch the x-axis. Okay, so it cannot be negative, it cannot be 0, and it certainly cannot be 1. Okay, so A represents the base, right? So that's why there is this restriction on A. The other thing that is important to note here is that x has to be positive. So x cannot be negative or 0. What's the reason behind that? Again, it goes back to understanding exponents. So in other words, if I take base 2 and I raise it to -7, can I get a negative answer? I can't. Okay, it doesn't matter what I raise base to, I'm never ever going to get a negative answer, and I'm not going to get 0 either. It doesn't matter how small I make that. Remember, of course, if I put 2 to the power of 0, my answer is 1. Okay, so that's why x has to be greater than 0. Okay, you cannot get 0, and you certainly cannot get a negative number when you raise a base to an exponent. Okay, so those things are important. Correct. Okay, so that's because A is the base. Why does it have to be 0 or 1? I think I've explained that. I'm not going to write it. Okay, is everybody happy with that? Let's jump in and do an example now. Okay, so again, sorry, let me just explain this bit to you over here. So in the case of the yellow graph, where they are saying y equals log a to the x, where a is a number between 0 and 1, okay? Remember what happened when we reflected the blue line over the y-axis. We ended up with our base being a fraction, okay? And that's what's going on here as well. That's why they're saying a has to be between 0 and 1, okay? And similarly, when we reflect this one over, oopsie, sorry, I meant to highlight it, not draw a line through it. Here, when this one is reflected over the line y equals x, it comes from the blue guy. Okay, so again here we could have y equals, you can't have 1 to the x because again it can't be 1, but 2 to the x, 3 to the x, 4 to the x, 5 to the x, etc., etc. Okay, so b is greater than 1, and that's why the base is greater than 1, and that's why a has to be greater than 1. Okay, all right, so now let's have a look at this example. Okay, so they give us a function. They tell us the function f of x equals log a to the x, and they tell us that it passes through 0.4 and -2. So this is a lovely sort of exam type question that you guys can expect. So the first thing that they are asking us to do is determine the value of a and hence the equation of f. All right, so Matrix, what do you think we need to do here in order to work out the value of a? Remember this over here means y.
Ma'am,
Yes, can you see it?
can we find the inverse of the logarithm function in order to the equation?
Okay, look, you can do that, but you can sub in first and then you can work backwards if that's what you want to do.
Okay.
So in other words, if you've got y equals log a x, just like whenever we're solving for a in any function, we need to sub in a point. Okay, so here our y is going to be -2. We've got log a, and then our x is going to be 4. And now you can work backwards. All right. So how would you write this if you wanted to go back the other way? We would write this as, this is really important. Anybody know? Our base is a. Oh, why has it done that? Our base is a. Our exponent is -2. And our number is 4. Okay, so being able to do that is really, really important. Have I lost anyone? No, you sure? You sure? Okay, so now, cool. All right, so now we can write this as 1 over a squared is equal to 4 over 1, and then we can cross multiply, so that would give us 4a squared is equal to 1, and then we could divide both sides by 4, so that means that a squared is going to be equal to 1 over 4, and now we need to take the square root. But remember, okay, a was our base. So whilst we can consider that there would be a positive and a negative answer for this, in this case, we would only accept the positive answer. Okay, so whilst a could be equal to plus minus 1 over 2, a always has to be bigger than 0. So therefore, this has to be the graph of y equals log half x. Is everybody happy with that? Cool beans. All right, so that's question A. Let's have a look at question B. All right, so here we've got write down the equation of the inverse of f in the form f to the -1x equals. Okay, so now our original function is a log function. Okay, they've given us a log function. Its inverse is going to be a what sort of function? The inverse of a log function is a
exponential function.
Exactly, Cassandra. Okay, an exponential function. Quite right. So that means if we now need to write down the equation of the inverse, right, we've now got to do an inverse of what we had. All right, so that means that we've got y equals log half to the x. So our inverse is going to occur when we switch our x and our y. So x will be equal to log half y. All right, and that means that we are then able to write this, all right, as the graph of y equals base to the power of x. Is everybody happy with that? Okay, so the other thing that we could do if we wanted to is instead of me writing it as f, I could write it like that. Okay, so this one is easier. It's when you have to go from here to here that normally causes an issue for matrix, or it becomes a sort of a little bit more difficult. Okay, everybody happy with that? That should be fairly straightforward. Spongile? You okay? You got a question? No? Okay, all right, no problem. Okay, so now question C. They've asked us to draw neat sketches of f and its inverse on the same set of axes. They love making us do questions like this, don't they? Okay, so very quickly, let's draw these. Okay, there are our axes. Maybe I should move them down a little bit. Right, okay, so our graph of the original function, okay, so f is going to look like what, matrix? It's that horrible one that I can never draw. Okay, so I'm going to start here and I'm going to do something like, can't believe I actually, that is horrible, but anyway, it's better than nothing. Okay, so that is going to be f. If we now have to draw the inverse, it's going to look like that. Okay, and of course, our line y equals x is that one over there. If they ask you to sketch, the other thing that you can do is you can find the y-intercept or the x-intercept. Okay, so here we would know, and hopefully you guys do know that the coordinates here would be 0 and 1. And of course, when this is reflected over the line y equals x, this would be 1 and 0. Okay, and similarly, if you had another point on the function, so for example, they told us here that it passes through the point 4 and -2. The point 4 and -2 might be over there, for example. That point will also be reflected on the other graph. All right, so that means that somewhere over here, this one has to go through the point -2 and 4 as well. Okay. All right. Now, domain and range of each function. Okay, so this is the horrid bit. Okay, so the blue one. What is our... Actually, let's start with the pink one. I think that'll be easier for you. Okay, so the pink one is the exponential function. The blue one is the log function. We were given the log function. We drew the inverse, which was an exponential function. Okay, so as far as our inverse is concerned, okay, what is its domain? Okay, x is an element of the real numbers. What is its range? Y is greater than 0. So here, this now swaps round with your log function. Okay, so here our our domain is going to be x is greater than 0 and y is an element of the real numbers. All right, is everybody happy with that? And then determine the values of x, which these functions are either increasing or decreasing. Both of them are decreasing for all values of x. So I'll just add that in as well. So both f and the inverse are decreasing, are decreasing for all values of x. Okay. Any questions? Okay, so I've talked you all to death now. You'll be pleased that, cool. Okay, 100% sure, guys. Here's now, I don't know if you feel you need to practice this. If it's too easy for you, I'm happy for us to move on. I just wanted to know if you wanted some practice writing the inverse of either of these. What do you think? Do you want practice with that, or do you think you've got it? Practice, please. Okay. All right, cool. Okay. So it's just these four. All right. So they have given you the function and they want you to write the equation of the inverse. So it just gives you, and you don't have to sketch these ones. You're going to get some sketching practice below. Okay. So try A, B, C, D. Nicole and I will be quiet. Well, Nicole's always quiet. It's only my horrible voice you have to listen to. We'll be quiet for a little bit and you guys just write the inverse of the function. Don't sketch them. Okay. We're going to sketch below. Sure, Aisha. Was it that you wanted me to go back to? Okay. Thank you, Nicole. I can tell you the boys I teach every day certainly don't think that, but anyway. All right. There we go. Okay, guys, off you go. Awesome. Well done, can you see there? Cool, Moronkoa. Yeah, no, this really shouldn't have taken you guys too long. Do you need some more time? Can we mark it? Done. Cool, Thelma. Cool, Ayobakwa. Okay, there we go. Just a few more of you are done now. Okay, cool. So that means as far as the first one, nice, yeah. So as far as the first one is concerned, Neo, do you want to tell me what you got for A? Or am I putting you on the spot here? Sorry, that's supposed to be a 5. Looks like an S. Okay, so you should have had that. With the next one, you should have had this. And then with your log graphs going back the other way, your inverse here should have been 4 to the x. And here it should have been, oh, I've made a mistake. All right, half instead of a quarter to the x. Okay, everybody happy with that? Happy, good. I'm glad, Aisha. Thanks, Lasedi. Good stuff. Good. Okay, so now things start to get a little bit more interesting. Okay, I don't know if you would prefer that I'm quiet and then we mark. I think it's good that you have an opportunity to practice stuff by yourselves. So there are 2 questions here. Let's see if we can get through both of them. And then I'll mark them with you. Okay, if you have any problems, just reach out to either Nicole or I, and we will help you. Okay, Matrix, off we go. Yeah, absolutely. We're here to help. Okay, so are you talking about question C and question D? Moronghoa?
Yes, ma'am.
Okay, I'm going to delete myself. Okay, everybody else, if you are continuing, just continue working. I hope I don't disturb you. I obviously just want to support Moronghoa through this. Okay, so let's just get our axes. Okay. So if you were asked to sketch the function that's been given to you, what did you determine the value of a to be? Moronghoa?
I found my A is 2.
Your a value was 2. Sorry, let me just, that's not what I got. I got a half. Did anybody else get a half? Okay, Moronghoa, let's just double check that. Okay, so you also got the half. Okay, maybe that's why you're struggling to draw this. I'm not 100% sure, but you should have got Moronghoa. You should have got that a was equal to 1/2, not 2. Okay, so let's start there. All right. So this is y equals a to the x. So when we go and sub in, 4 is our y. A is what we want to solve for, and that's equal to -2. Okay, so it's very similar to that other question that we did. All right, so we would have to write this as 4 equals 1/a squared, and then we would have to cross multiply. We've actually done this. Okay, so cross multiply. Does that make sense?
Yes, because I made my 2 not negative. That's where I think I'm.
Oh, there we go. Okay. All right. As long as you found your mistake. Okay. So just fix that up. And then you're going to take that graph and you're going to reflect it. So now that you know what the graph looks like, okay, it looks like this. Okay, so this is your F graph over here. And that's what it looks like. So now what they want us to do is they want us to determine the equation. Sorry, are you talking about this one over here? So now when it comes to sketching, okay, so what did you work out to be the reflection of the graph about the y-axis? What did you get there as your answer? Y equals?
I didn't do that. I did not.
Okay, so you need to do question C and D before you can do question E. Okay, so I've sketched F for you. G is its reflection about the y-axis. H is its reflection about the x-axis. And then they want you to draw its inverse on the same set of axes. Why does it keep doing this? Yeah, that's very true, Nicole. You have to learn the theory. And it's so in every section of maths, you absolutely have to learn the theory and the concept behind it and understand why. And only from there can you begin to answer the questions, definitely. Otherwise, you're just always operating in the dark. Cool, Thelma, well done. Did you do 3 and 4? Wonderful, well done. Okay, so Matrix, we've only got about 5 minutes left. And I obviously just wanted to be able to go through this with you. Are you guys close to done, almost done, not done? How's it going? Cool, Neo. All right, can you see there? Cool, Marankoa. Cool, Spongile. Okay, so unfortunately we are rapidly running. Cool, Ayobakwe. And we are unfortunately running out of time. So here are the answers. Instead of me working, if you want me to work through anything with you, then I'm obviously more than happy to do that. Okay, so this is question 3. So in 3A, you should have got A as a half. Then in 3B, the inverse, you should have got f to the minus 1x equals log base half x. Then in question C, the equation of g, the reflection in the y-axis. So you should have got g of x equals 2 to the x. For D, the equation of h, the reflection of f in the x-axis, you should have got h of x equals minus half to the x. Question E, that's what we were talking about, Morongoa, was all of these diagrams. Okay, so if you have a look, they've been labeled really nicely and drawn far better than I think I could. Okay, so there's our original function, the reflection of it over the y-axis, g, the reflection of it over the x-axis, h, and then of course also our reflection over the line y equals x, our inverse function. Okay, was that fine? Was everybody good with that?
Yes, ma'am.
Oh, okay, all going well. All right, lovely. And then, of course, they asked us these questions about domain and range. Now, what they've done here, this is just a different way of writing things. When I was writing x as an element of the real numbers, that's what they mean from negative infinity to positive infinity. When they write the range of f as y as an element from 0 to positive, that's us writing y as greater than 0. If you want to use interval notation, you're more than welcome. And then here again, we would have said x is an element of the real numbers. And again, here we would have said the range of g, y is going to be greater than 0. Okay, everybody happy with that? Any questions? And then we'll just quickly look at number 4. All right, so there was question 4. Again, I think they just drew it better than I could. All right, so you should have got that A was equal to 4. In B, your inverse is 4 to the x, and then in C, that was your diagram of both. Are there any questions? No. Okay, are you all feeling good? Thumbs up, thumbs down. Cool, Thelma. Cool, can you see? Thanks, Lesedi and Morongoa. Cool, Jared. Nice to hear from you. Oh, Neo, why do you look sad? Not all the questions. Okay, Spongile. I'm sorry, time is always chasing us, isn't it? But you can always get the video again, fast forward to the point where the questions are, try and work through it and then mark it. Okay. Cool, Orotile. Cool, Valerie. Cool, Ryle. All right, well, guys, it is time for the quiz tonight. Hopefully you can go and do that after this. It's always nice just to make sure that you guys know what's going on. And one of the things that we're going to start doing is bringing the quiz memo into our discussions and our lessons. We obviously try not to take too much time on that. But yeah, please go and do the quiz. And yeah, goodbye from us. And we'll see you again next Tuesday. Hope you have a great weekend. Thank you, Nicole.